Hi, salam sejahtera to Madam. My name is Morgan, and this is BEE 11203 Ordinary Differential Equation Group Assignment. And I am from Group 7, and this is my group members, which is Aiman Fatina binti Muhammad Kamal, Nurin Usni binti Azimi, Nur Shahira binti Ahmad Sawawi, Morgan, which is myself, and Muhammad Khairul Hadi bin Rahman. So there are altogether 4 questions in this group assignment, and we are going to do all the questions separately by using a hand calculation and also an appropriate software to check the answers.
Assalamualaikum. My name is Aiman Fatina binti Muhammad Kamal. My matrix number is DE20094. I will do question 1 for this assignment, and I will use dual language, which is Bahasa Melayu and Bahasa English for this presentation. Okay, for question 1A is actually prove the ODE. Okay, so for this equation, I solve it by using two methods. This one is exact method, but I found out this is a non-exact. Therefore, I try to solve this using non-exact method. I refer at page 28, book Engineering Mat 2. For the final answer, I get this one. And then it is quite similar with the simulation. For method 2, actually I using homogeneous equation. And then this is the final answer. Also same with the simulation. Therefore, we can conclude that 1A, number 1 equation is actually homogeneous equation but non-exact, non-separable. Therefore, this is still ODE. In 1A2, I try using homogeneous, and then I try to check whether this is a homogeneous or not, and I try to check, and then it is stated that it's a non-homogeneous equation. So for chapter 1, actually we did not cover to solve homogeneous non-homogeneous problem, but I tried to research how to solve it, and I found this method. So the final answer is actually this, and quite similar with the MATLAB simulation. But if I use the other calculator, it will state that this is a non-homogeneous. For question 1b, actually, it wants us to solve this equation to prove this equation can be this. Okay, and then for the first one I try using the second one I try using Bernoulli, but actually I'm using Bernoulli first, and then Madam said cannot because it's not in syllabus, so I try using homogeneous. So this is the final answer, and we can check this with our simulation, can be proven. Therefore soalan minta us to prove that the equation can be like soalan minta, so this also the same. Okay, with the soalan, move to Bernoulli and answer this can be proven by simulation, same like the simulation. And then the final answer, when we insert the C, is also same with the equation. Question 1C, actually using LDE. Final answer here are same with the simulation. And C number 2, final answer, this one, is also the same, but for the simulation, I'm using Y and X, while in here, I'm using I and T. Okay, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Hai, nama saya Nur Husni binti Azmi. Saya akan terangkan question 2. Selesaikan y double prime tambah 6y prime tambah 13y sama dengan eksponen.
Calculate the complementary function yc. Jadi y double prime tolak 6y prime tambah 13y sama dengan kosong. Kita gantikan y dengan m. Jadi m square tolak 6m tambah 13 sama dengan kosong. Jadi kita selesaikan guna quadratic formula, iaitu m equal to negative b plus minus square root b square tolak 4ac bahagi 2a. Masukkan nilai a, b, c iaitu a sama dengan 1, b sama dengan negative 6, c sama dengan 13. Jadi kita dapat m sama dengan 3 plus minus 2i. Jadi formula untuk yc kita guna two complex conjugate roots, iaitu alpha plus minus beta i. General solution yx sama dengan eksponen ax kurungan a cos beta x tambah b sin beta x. Masukkan nilai eksponen 3x bracket a cos 2x tambah b sin 2x. Question B, calculate the Wronskian W. Kita kena jadikan y1, y prime 1 dan y2, y prime 2. Jadi y prime 1 sama dengan negatif 2 eksponen 3x sin 2x tambah 3 eksponen 3x cos 2x. Untuk y prime 2 sama dengan 2 eksponen 3x cos 2x tambah 3 eksponen 3x sin 2x. Jadi kita masukkan nilai dalam formula Wronskian yang kita tahu, y1, y2, y prime 1, y prime 2. Kita masukkan nilai dan darab silang. And then kita selesaikan, dapat Wronskian sama dengan 2. Dapatkan nilai u, kita gunakan formula yang kita guna juga, iaitu negative integration of y2 fx divide a w dx plus a. Kita dapat u sama dengan 1/8 cos 2x eksponen 2x tambah 1/8 sin 2x eksponen 2x sama tambah A. Untuk V, kita guna formula yang kita belajar untuk dapatkan nilai V, iaitu integration of y1 fx divide A W dx plus B. Kita selesaikan, kita dapat V sama dengan 1/8 sin 2x eksponen negatif 2x tolak 1/8 cos 2x eksponen negatif. Akhir sekali, kita gunakan general solution variation of parameter y sama dengan u y1 tambah v y2 yang kita dah cari pada awal-awal tadi daripada A dengan B. So y, masukkan nilai u 1/8 eksponen negatif 2x cos 2x tambah sin 2x tambah A, darabkan dengan y1 eksponen 3x cos 2x tambah v 1/8 eksponen negatif 2x sin 2x negatif cos 2x plus b, dan nilai y2 eksponen 3x sin 2x. Kita darabkan nilai ni dan kita selesaikan, kita dapat 1/8 eksponen x tambah eksponen 3x kurungan A cos 2x tambah B sin 2x.
Itu saja daripada saya. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nushaira binti Ahmad Safawi. So I answer question 3, which is homogeneous system of first order differential equation. So for E, I got the answer is this y x equal to c1 1 exponent 7x plus c2 1 negative 5 exponent x, which is this is yc by using this formula, which is y prime equals to ay. And for B, I using this formula y prime equals to ay plus g, and I got the answer is yc equals y equals to yc plus yp, which is I got the answer is c1 1 exponent 7x plus c2 1 negative 5 exponent x plus 5x plus 5x plus 6 and exponent 7x. And for P2, I find the value when we substitute the y0 equals to 2 1, so I get the answer is y equals to negative 10 3 1 1 exponent 7x plus 1 3 1 over 3 1 negative 5 exponent x plus 5x plus 5 5x plus 6 exponent 7x, and that's all. So this is the simulation using MATLAB for question 3A. So this is the proof that the calculation and the simulation get the same value. And this is for B1. Also using MATLAB, the calculation value and the simulation value are same. And this is the proof that for question 3B2 also same with the calculation value. Thank you.
Hello, my name is Tirmuga. My matric number is DE200111. Today I'm going to discuss about question 4 from our assignment. So question 4A, the question is calculate the inverse Laplace transform s divided by s square plus 2s plus 4 by completing the square. So we are using the method of completing the square. So we need to bring out the denominator as square plus 2s plus 4, and then we need to take out the middle part of the denominator. We need to times with 1 over 2 and then square it, so we will get like 1. So we use the 1, we need to plus 1 and minus 1 to the denominator as well as the upper part of the denominator s. So we will get like a s plus 1 minus 1 divided by s plus 1 square plus square root of 3 power of 2, sorry. So we need to change it to inverse Laplace transform, and then we will get like the answer exponent power of negative t cos square root of 3t minus 1 over 3 exponent power of negative t sine square root of 3t. So next I'm going to discuss about question 4b, which is evaluate the inverse Laplace transform s divided by s square plus 1 times with s square plus 2s plus 4 using a partial fraction. So in this question we need to use partial fraction method. So as we use the method, we will get as plus b divided by s square plus 1 plus with cs plus d divided by s square plus 2s plus 4. And then after do the calculation, we will get a plus c equals to 0, and then 2a plus b plus d equals to 0, and then 4a plus 2b plus c equals to 1, and then 4b plus d equals to 0. And after do all the calculation, we will get like a 3 over 13, for b 2 over 13, and c negative 3 over 13, and for d is negative 8 over 13. And then after you get the value, we need to transform the question into a inverse Laplace transform. So after we inverse the question, we will get like a 3 over 13 cos t plus 2 over 13 sin t minus 3 over 13 exponent negative t cos square root of 3 t minus 5 over 13 exponent of negative t sin square root of 3 t. Thank you.
Assalamualaikum. My name is Muhammad Khairul Hadi bin Abdul Rahman. My metric number is CE200067. Okay, ini saya akan menjelaskan question 4 bagi projek ODE bagi grup 7. Saya akan menerangkan bagi question 4C, itu RLC circuit with L yang diberi is 1 Henry, resistor is 2 ohm, and the capacitor is 0.25 farads. And the ET as given in the figure question 4C. This is the figure that they given. Based on my calculation, by applying the KVL in loop in the figure, I use the equation L di dt plus IR plus 1 over C. Untuk ini IT dt equal sin t minus sin t h t dalam kurungan t tolak pi. So by applying the, just masukkan ni dalam dia punya equation ni, so I got di dt plus 2i for t0 it dt equal to sin t minus sin t h t minus pi. For the question D, based on the question C, I from the answer L di dt plus 2L I plus 4L dalam kurungan it dt L sin t minus inverse L sin t h t minus pi. So the answer that I got is, the final answer that I got is IT equal to inverse S over S cos 2 plus 2S plus 4 plus inverse S dalam kurungan over S cos 2 plus 1 S2 plus 2S plus 4 and minus inverse S exponent kuasa negatif XS S2 plus 1 S kuasa 2 plus 2S and plus 4. For the MATLAB that I use is for 4C is sin X IS 1 negative exponent X plus ni S kuasa 2 plus 1 S plus 2 plus 4 over 5 minus 1. I place for the question 4D, the current through inductor for graph function question ADET is pi, estimation time at 0 is 1, is power kosong, initial condition. For I use II equal x 1 for VC and x is 2. Subplot 2, 1, 1, plot line white is 0.75 grid on. So X label time is second and Y label is current A. And so model series is RLC circuit function. Function Y is RLC EKTSCN. So R is 2 ohm, L is 1 Henry, capacitor is 250, exponent T is equal to 0.25. So VI is 1. So Y is I put is negative R over L, negative 1 over L, 1 over C, 0. Right? Times X plus 1 over L, 0, and times for VI. That's all for me. Thank you.